All right, welcome back to the channel. So in today's video, we're going to be discussing on how to get a Gen 5 GM engine up and running after it's had an aftermarket camshaft installed. As we all know, 2014 and newer GM pickup truck and SUVs, a lot of the 2016 and newer GM LT based engines, they're plagued with DOD AFM failure issues. So obviously what most guys do is they'll go ahead on and pull out the factory parts. They'll install an aftermarket camshaft with a set of aftermarket lifters, and then they need to get their vehicle up and running. Whether they're wanting to tune it themselves or whether they're wanting to drive it to a tuning shop, they need to make some adjustments in the tune to actually get the vehicle to where it will actually start running idle. So let's go ahead on and dive into this base file, and we're going to discuss the principles of tuning Gen 5, and I'm going to show you guys the changes that need to be made to get your vehicle up and running. So before we get into this, I'll need to go ahead on and make sure that I'm going to put a disclaimer out there. This is for educational purposes. We are going over the principles of Gen 5 tuning as far as just making minor basic adjustments. This is by no means a complete how-to. I will eventually go through, basically a whole playlist on how to tune Gen 5. We'll dive deeper and deeper into this, but this video is just me rolling out the fundamentals of it. So also note that I've selected a engine size that may not be the same as yours, and I have selected a camshaft that may not be the same as yours. So again, we're going to go over the principles. The tune-up that we're going to use for today's video is going to be based off of getting your vehicle running and driving. This is not meant to go wide open throttle on. This is literally just to get you up and running. So we're going to go ahead on and open up our stock file. So to do that, we're going to click Open File. And then today I want to use a 2015 Chevy Silverado with a 5.3. This seems to be the most common engine that I see when I'm tuning trucks. If you've done just a DOD Delete cam, we'll go on and get this out of the way. You've done just DOD Delete cam and it keeps all the factory VVT and everything else. All you got to do is just go under Engine. You're going to go under Fuel, Lean Fuel Savings, and where this DOD is, where you see where it says Enable, we're going to just disable it. So whether you've got an aftermarket, larger camshaft or a stock DOD Delete camshaft, that's the first step, is going ahead and make sure we turn off DOD. So with that being said, again, if you're stock camshaft but just DOD Delete, you can go in and save this file, send it in, you're done. As I already said, though, we're going to go ahead on and tune for the BTR Stage 2 truck cam, which is the L83 truck cam. So let's go ahead on and dive into this. Now, I want you guys to understand that Stage 2 truck cam can drive on stock torque converter, and it does drive okay. It is not perfect, but it does drive okay. Traditionally with the L83, I really like to run the Stage 1, but it seems like I get asked about the Stage 2 more than anything. So in order to get a Stage 2 idling, we're going to go over to idle. And as always, we're going to go ahead on and increase our base desired idle RPM. So to do that, we're going to click this base under base set point. And anytime you're working on Gen 5 engine, you want to make sure your changes are done in a uniform manner. We're going to go ahead on every idle RPM change you'll see. We're going to make the same change everywhere. So to start off, we're going to click the top left and we're going to type in 150 because an L83 on a Stage 2 cam, 150 RPM over stock is about what it wants. You can adjust this up or down depending on what you want, but from my experience, 150 RPM seems to be on the money. The next thing we're going to do is rolling idle. So we're going to click rolling. Now, if you're going to notice, the axis right here is mapped gear position. That's going to tell you whether you're in park neutral, first, second, third, whatever. And then this is vehicle speed at the top axis. So this changes your desired RPM as you increase your speed. So what we're going to do is we're going to drag from 0 to 5, and we're going to add 150 here. Now, stock torque converter, this over here may be too much. So right here, 18 mile an hour, let's just call this 725. And that'll keep us covered because as you're rolling, you want to have a little extra RPM there. It's going to be for your accessories, and it just overall smooths the way the vehicle drives. So we're going to close this out. Next thing we need to do, we don't need to touch rollback assist. We don't need to touch launch assist. We need to go under startup, and you're going to start off with park neutral. And as we add the 150 in the other areas, we're going to add the 150 here. Add, close this out. We're going to also go to in gear, do the same thing, click top left. We're going to add 150 here. Now, the next thing we're going to talk about, we're going to go under adaptive idle control. Anytime you see speed control or you see these two words, immediate and predicted in Gen 5, just know that immediate is when the ECU is wanting to remove the torque as fast as possible, which is the best way to do that for the ECU is going to be ignition timing based. If you see predicted is going to be a little bit slower of a method. It's going to be the airflow control, so it's going to be more like your throttle body. This right here is a good way of making an adjustment with a rowdier camshaft, like especially a Stage 2 truck cam, which I know Stage 2 doesn't sound big, but it's actually a decent sized camshaft. So Stage 2 truck cam and L83, you may need to increase your immediate idle control. It'll give the ECU a little bit more control. Now, if it's an L86, you probably won't have to touch this. The L86 will absorb the Stage 2 truck cam much better than the L83 does. So again, just note this is timing. This is throttle body based. So if you wanted to increase this, say we wanted to make sure it has a little bit more idle control, we just come up here and we can just type in multiply times 2. And that would be fine right there. So now we're going to go under torque, idle torque reserve, and we're going to go speed control reserve. Now this, I've seen guys talk about you need to decrease this, you need to increase this. Nope. All you actually need to do is anytime you see your axis where it's got an underline on it, you can make a change there. So you notice this desired RPM, we just need to increase this, the 150, just like what we did on our other tables. That's the only adjustment this table needs. You don't need to make any other changes to it. It's very, very, very rare that I ever have to make a change in this actual table, and it's usually when we get to the much, much bigger camshafts. Anyways, we can close this out. Next thing, this external load table. If you've been doing research on Gen 5 idle tuning, I'm sure you've come across several videos that discuss this external load, and they don't teach you the right way. I'm going to show you the right way to get this stuff done, but just know that if you've made any changes to external load ever, put it back to stock first. So the only change we need to make on this external load is the same as what we just did. This RPM, this is desired RPM, and we're going to add the 150 here. And we can just add it all the way across the board. And that's it. We don't have to touch this table ever again. We don't need to touch limit, offset. All that stuff is completely fine. Next thing we're going to do is we're going to go under airflow. Now, so you guys are aware, Gen 5 is very heavily VE based. Your volumetric efficiency table really needs to be dialed in. But again, I'm teaching you guys how to get your vehicle started, running, and driving. Again, this is not for a final tune. So what we're going to do is, just to keep this simple, we're going to do math only. So the first thing we're going to do is we're going to go to airflow, dynamic, and this high RPM disable, we're going to make this 100. And high RPM re-enable, we're going to make this 50. So with that being said, mass airflow sensor table, you can pretty much leave it stock. Stock table will cover you. The stock, it's actually kind of rich. Again, do not go wide open throttle on this tune-up. Just if you're going to be getting in a higher load whatsoever, please put a wideband in your vehicle and tune it properly. But for now, we're going to leave MAF calibration alone. So the next thing we need to do is we need to go under cranking airflow and torque, and we're going to go into our base airflow table. Now this is kind of more like your traditional old Gen 3, Gen 4 style startup tables. So this is going to be in grams per second. So all we need to do is go to the top left, and we're going to add 3 grams per second, plus send it in. The next thing is going to be the split CLO. It's going to be the same thing here. We're going to go top left. We're going to add 3 grams per second, and we're going to send it in. Next thing, cranking VE. Now we're going to make an adjustment to this table, but just so you're aware, with this camshaft, if your VE table is dialed in correctly, you do not need to change this right here. If you are in MAF only mode, which again, I only talk about MAF only mode and you using MAF only mode during the initial get it running process. By the time you're finished tuning your vehicle, you need to be in the hybrid mode where you need to be back where your VE table is calibrated, your MAF table is calibrated. But again, for initial startup, we're going to be in MAF only mode. So we need to reduce this cranking VE. We're going to drop this down. We can just highlight top left and just type in the number 80. And that's going to reduce our cranking VE 20%. This is a percentage based off of cylinder air mass and your VVE table. That's what this is looking at. So again, if your VVE table is dialed in, no adjustments are necessary, but for now, we're going to make that adjustment. So we don't need to touch anything under speed density right now. If you're doing VE tuning on Gen 5, just understand that it's just like Gen 4, where you go to edit, virtual volumetric efficiency table, and this is your VE table. This is a factory VE table for right now. So this is where you'll be making those adjustments. But again, in this video, we're not making adjustments here. Next thing is going to be variable camshaft. So this one is actually pretty cool. I'm glad BTR did this. So with the BTR camshaft, you're not locking out VVT. You're actually just limiting it. You're putting a 4-degree limiter into it. So the cool part is BTR already did the adjustments for us. So Brian Tooley and James Short got on the engine dyno. They figured out our optimal VVT settings. And so we can actually just download these settings. So we're going to pull up their website. So I've already got it pulled up. But BrianTooleyRacing.com, you find the camshaft that you're going to use. Again, we're using the Gen 5 Stage 2 truck cam. So what we're going to do is we're going to scroll down and you're going to notice this download button. So right here, you'll see L83 Stage 2. This is a PDF file that shows you the VVT settings that you need to use. So we're going to go under downloads. This is going to tell you, this is our cam specs. This is our fuel lobe size. This is going to be our VVT target angle. So we'll just keep this very simple. So if you notice how RPM starts at 4,800 and it goes up in 200 RPM increments up to 7,000. So we can actually make our table the same. So what we're going to do is I'm just going to go under watt desired angle and base. Now this is the desired angle, obviously at full throttle. We're going to have other tables that we're going to make adjustments on, but we're going to change our axis. And this one and this axis change is going to make the changes to all the other tables as well. So we're going to click RPM. And again, from 4,800 RPM up, he did it in 200 RPM increments of 48, 100, 5,000, 5,200, 5,400,
6,600, 800, 6,000, 6,200, 6,400,
6,600. Now you're going to say, well, hey, Matt, his table goes up to 7,000. Well, first off, we're not going to run this camshaft over 6,600. But also just note that anytime the axis ends in any configuration on HPtuners, if you're using like at least for GM, it's always going to reference the last line. So if the axis stops at 6,600, even if the truck's revving to 7,600, it's still going to reference the last VVT table. So if you look from 6,200 up, we're at 4 degrees. If we have 4 degrees and 6,600, it's going to be the same everywhere else. So we're 100% good. Anyways, but now that we've made our axis change, just understand that it's always going to reference the last area of the table. So if we go back to their settings, you'll notice that from 6,200 up, it's at 4 degrees. So it's going to cover us completely. All right, so now that we've got that zeroed out, we're going to go back and look at our tables to see what they show. So they're showing 1 degree at 5,200, then 2, then 2.5 and 3, 3.5 and 4. So we're going to go over to 5,200. So we'll zero this out. 5,200, we want 1. And if you can't see this decimal, just so you guys are aware, if you need to add or decrease decimal points, you just click add, or you can subtract it. So we're going to need a decimal point with a half showing today. We're going to go back 5,400. We're at 2 degrees. 5,600. We're at 2.5. Then 3. Then 3.5. And then we're going 4 degrees from 6,200. And we can confirm that again right here. 4 degrees from 6,200. So with that being said, that's our wide open throttle table. So we're going to go ahead on and copy this, okay? We're going to click top left and we're going to click the copy button. Now, if you'll notice how all these are now like pinkish reddish color, that means that the axis has been changed. Under desired angle, we can go ahead on and add our tables in. So we can click this right here. We can click paste. We can go down to the bottom, click paste, and then we can actually click the whole table. And then this is interpolate between vertical bounds. So now our table is exactly the same as what BTR had on their website. Now this is for part throttle, or just anywhere that's not watt. And this low, medium, high is based off of barrow pressure. But again, just to be uniform, we're gonna just make it all the same. So we're gonna copy this table. We're gonna close this. We're gonna paste this over into medium. We're gonna paste it over into high. Now again, GM references the intake camshaft on Gen 5 engines. Ignore this exhaust camshaft. We don't have to put anything in here. So now that's done, let's keep moving further. The next what we're going to do is we're going to go under fuel, and then we're going to go under oxygen sensors. Now this is going to be for initial tuning. I want you guys to understand that long-term fuel trims are all based off of your own opinion. I don't like to use long-term fuel trims because I don't like to let the ECU learn bad habits. If you guys want to run long-term fuel trims, you're more than welcome to. But anyways, for this procedure, I'm going to go ahead and disable long-term fuel trims. So you're going to go to minimum ECT. We're going to type in 491 because, again, I like to be uniform in my adjustments, so it makes this match. Now, if you just do this, it's not going to stop long-term field trims. The next thing we're going to do is under minimum map versus barrow. And let's just type in a manifold pressure that the truck can't reach. So we can go to 200 kPa, and that's going to be boost. That's basically 14.5 pounds of boost. So we know we're not going to see that, so we're good. So we're going to close that out. We don't need to make any other adjustments in here. All right, so the next thing we're going to do is we're going to go under fuel cutoff, deceleration, fuel cutoff. Now, this is to help you guys. I've had deceleration, fuel cutoff in certain vehicles cause an idle crash. So we're going to go ahead on and get this open out of the way, just like what factory would. So you go to compare, open compare file, and we're going to open back up the same tune that we're on. So that way, if we can actually click our show differences button, and you'll see it's our show differences at 0. So what we're going to do is we're going to add 150 RPM to this. Now, the reason why I'm doing it this way is because if you look, this 980 number, yeah, I know some guys can just look at it and say, okay, we need to go up. If we're adding 150 to it, it's 1130. But just to make it simple, put your compare file to the same file that you're on and go to show differences. And you can just type in a 1.5 right here and then a 1.5 right here. And this is going to keep deceleration fuel cutoff from causing an idle crash. It doesn't really do it on Gen 5, but again, anytime I'm tuning on anything, I try to be uniform in all of my adjustments. So for right now, we don't need to make any type of rev limiter adjustments because, again, we're just trying to get the vehicle to start and run and drive. All right, so the next thing we're going to do is we're going to go to Spark, and we're going to go under this VCT table. And this VCP spark, this is a spark modifier. So what table is doing, depending on the variable cam timing degree that the camshaft is at, this is going to add timing. So in GM vehicles, Gen 5 especially, they're going to take the variable camshaft and they're going to heavily retard the cam timing at very light load. Basically, it's just for fuel mileage. Because of that, when you retard that camshaft, 20, 30, 40 degrees at light load, you have to add a bunch of ignition timing to actually get the thing to be happy. So in our application, we don't necessarily need to do that. So we can just take this table and we can just zero it out. That's the only timing adjustment we need to make right now. Again, we're just getting this vehicle to start run and drive. So we don't need to touch retard, we don't need to touch dwell, we don't need to touch knock sensors. So now we're moving on to torque model adjustments. Now this is where shit usually hits a fan for a lot of people. When you've got an aftermarket camshaft, you've got to make adjustments to your torque model. Basically what happens is when you put in a larger camshaft, you got to idle the thing up, and it's also less volumetric efficient at idle. So therefore, it's going to show to move more air mass. So what that does, that actually causes the ECU to see an increase in idle torque. So guys will cam it, they'll increase their idle RPM, they'll do all the stuff that we've done, but they'll get it running, and then the ECU's pulling timing. I mean, it'll be like, they'll be idling at -10, -20, -25 degrees of ignition timing because the ECU is trying to reduce the amount of torque it wants at idle. So just so you're aware, L83 engines, which I've actually said in a couple other videos, but L83 engines, L86 engines, truck engines seem to idle in factory form, they idle right around 0 foot-pounds of torque. So basically what we do is, let me pull up a data log. I'll pull up a data log from a truck that I was helping a guy out with some issues on. But you'll see that we have 0 pedal engine torque. Now, the best way of doing engine torque is you want this number right here to be as close as possible to 0 while at idle in park as possible. The best way to do it on the trucks. So if, normally when you cam a truck, this number right here would be, it'd say plus 50, it'd say 50 foot-pounds of torque. So if that's the case, if you see this is a positive number, you need to reduce the torque in your virtual torque model. If you see this as a negative number, like it's shown here, you need to actually add some torque here. So we're going to ignore that this is -30. We're just going to say this was positive 50, right? So again, we're going to go to our base file and we're going to tune our virtual torque as if we've got, L83 with the BTR Stage 2 truck cam. So I'll tell you that the best way to look at torque is the difference in your VE table. So say you need to reduce your VE table by 30%. That also means you need to reduce your torque table by 30%. It's all VE based, which again, we'll go into a deeper video. I'm just trying to figure out the best way to explain this to you guys. Anyways, to make this adjustment. So with the Stage 2 truck cam, what we're going to do is we're going to go under Edit and we're going to go to Virtual Torque. Now we're just going to worry about our idle regions. So what we want to do is, I know for a fact that a Stage 2 truck cam usually wants the idle RPM region reduced by at least 25%. Most times it's right around 30%. So we're just going to do 30% because 30% will get us started running. So just note that all our torque settings, this is all linked together. So whatever change we make in this top table, it's going to automatically make the changes in the tables below that. So first thing we're going to do is we're going to go up just to our idle RPM, 500 and 700. We've got negative numbers here. So in order to reduce a negative number, you actually have to add it. So we're going to do 30%. So we're going to multiply times 1.30. And we're going to click multiply. Now what we're going to do is on the same two columns, is 500 and 700. We're going to reduce this by 30%. So in order to reduce a positive number, we're going to type in 0.7. So we're going to take 30% off of this. And then what we're going to do is we're going to just highlight 500 and 700, and we're going to actually interpolate between vertical bounds. So you can actually see what this is doing to our torque model. And what we're going to do is we're going to click 700 over to 1200, and we're going to interpolate between horizontal bounds. Now again, this right here should get a Stage 2 truck cam and L83 up and running and idling really solid. The 30%, it could be 20%, it could be 5%, it could be 10%. You've got to play with it. Watch your 0 pedal torque. And again, try to get your 0 pedal torque in your channels, in your data log. Try to get your 0 pedal torque on a truck, and on a pickup truck that with the automatic, roughly 0 foot-pounds, okay? So now with the cars, a lot of the cars also like that number to be 0, but sometimes they may like a positive 12. You've got to watch your ignition timing, and you've got to watch 0 pedal torque and dial it in for yourself. But again, for the purpose of this video, I wanted to show you guys how to get a Stage 2 truck cam up and going in a 2015 Chevy Silverado with a 5.3. What we just did in our torque model is going to get the job done. So now that we've made that change, what we got to do is we got to extrapolate coefficients. So we're going to click this button, and that's going to automatically populate our torque model for our air mass table. So now we've got to switch over to our map base table. Now, if you're also doing flex fuel, you got to do it through your E85 and air mass and E85 map sensor tables as well. But we're going to click map and we're going to do the exact same thing. So 500, 700, because it's a negative number, we're going to multiply and we're going to add 30%. We're going to down to the bottom, and because it's a positive number, we're going to reduce this 30%. So again, we're going to highlight these two columns. We're going to interpolate between vertical bounds, and then we're going to go from 700 to 1200, and we're going to interpolate between horizontal bounds. We're going to extrapolate coefficients. Now, again, if you're flex fuel, you might as well just go ahead and make this adjustment even if you're not flex fuel. But if you're flex fuel, you got to do this on E85 air mass. So again, multiply 1.30, scroll down, multiply 0.70, copy, interpolate vertical. 700 to 1200, interpolate horizontal, extrapolate coefficients, move on to E85 map. So we're going to multiply 1.30, scroll down, multiply 0.70, highlight, interpolate vertically, 700 to 1200, interpolate horizontally, extrapolate coefficients. So now that's got your torque model adjusted. Now your vehicle is going to actually idle properly. So we realistically don't have to do anything else in this tune to get a Gen 5 vehicle up and running. Just so you know, stage 2 camshaft can cause a misfire counter. So if you want to adjust that, you're going to go under engine diag. We're going to go under misfire, revolution mode. Usually you just make sure that 32.767 is how to disable. So that part is fine because we're only really concerned about idle misfires. That's usually the only place that will show up. So under idle not moving, we can just make this 32767. Close this one out. Idle 2, same thing, 32767. Close it out. Normal, below 3,000 RPM, 32767. Normal 2, below 3,000 RPM, 32767. SCD mode idle, same thing, 32767. Off idle, 32767. Idle 2, 32767. Off idle 2, 32767. All right, so the next thing we need to do is we need to go under engine diag airflow. And this is going to be this PO106 if you're MAF only. This code will be thrown if your V table is not dialed in. So we need to actually go in and get this thing out of the way. That way we're not having any issues. So minimum ECT, we just make this 493. No, we're not going to override that parameter. Max ECT, we're going to go negative 40. And then this PW68 is also an airflow correlation issue. So we can just add a 0 to the end of this and make it 8,000. And that is just to get your vehicle up and going. We don't need to make any other changes in this tune-up. Save as. Make this BTR stage 2 base. Save it. Send it in your vehicle. So that's going to wrap up today's video. Again, I will make plenty more Gen 5 videos, but I just wanted you guys to know exactly what's needed to get a L83 to start off with a BTR Stage 2 camshaft, whether it's Stage 1, Stage 3, whether it's Texas Speed, whether it's NK Performance, no matter which cam company you're using, what we did in this tune-up is going to help you guys get your vehicles up and going. If your camshaft is bigger, you're probably going to need higher RPM for idle. If your camshaft is smaller, you can go lower. If your camshaft is smaller, you may, on the torque model, instead of doing 30%, you may need to do 5% or 10%. If your camshaft is bigger, you may need to do 40% or 50%. Just again, watch zero pedal torque. But anyways, guys, I know it's a lot. I'm going to keep going, and I'm going to keep trying to figure out a way to get this more and more simple to you guys. But thanks for the likes, the comments, the subscriptions. We're going to have some really cool videos coming this week. I've got a 56 Chevy that we're going to tune. We've got a LSX 454 Impala. We've got an LSA 442. So if you haven't already subscribed, please do, and I'll see you guys tomorrow.